You guys know what torque is, right?
Torque is RF sine theta.
But what does that mean?
We're gonna show you.
We're gonna show you.
To the seesaw! Here, Jacob is exerting torque on the seesaw. His force is downward, and the force he's exerting is his weight, which is his mass times acceleration of gravity.
So now we have two forces of torque on either side, one going counterclockwise and one going clockwise.
We're measuring something.
So why is Jacob on the ground but Lizzie's higher up? Well, let's look at the torque that they're each actually putting on the seesaw. So we see that Jacob has a higher mass and is putting more of a force on the seesaw, and he's also a greater distance, meaning that there's a greater radius from the center of the seesaw. So that means a greater radius and a greater force, which means that there's a greater torque. So the seesaw is uneven towards his side.
To demonstrate that we can change this, I can move up on the seat, and all of a sudden Lizzie will go down.
See? We decreased the radius to the center of the seesaw, and so now it's even between the two sides.
That. Okay, so as you can see, Lizzie and Emma are the same weight, or ideally close to it. What happens with this is sitting at the same distance makes the radius about the same. This puts them at equilibrium, and therefore they, don't bounce.
Or torque is the same.
That's the word I was looking for.
Equilibrium!
See, now we achieved equilibrium with a little bit of force on the ground.
If we had more corn dogs, we probably would have been more even.
We can influence the amount of torque based on how much we push up from the ground, which counteracts the force of gravity that would normally create the torque going downward.
Yay!
So you see, when I press this way, nothing happens to the seesaw. You know why? Because I'm pressing parallel to the way that this is. But if I go perpendicular, then it actually moves more because it's making a 90-degree angle with the line of the seesaw.
So the maximum torque that's going to be applied is that when the force is applied perpendicular to the center line.
Down.
I'm pressing upward and Jacob's pressing downward. We're both going the same way around the circle. And so because of the fact that we're both going basically counterclockwise around a circle, it goes the same way as far as the movement of the seesaw. But if Jacob and I both press up, not that heavily. If Jacob and I somewhat press up, nothing happens to the movement of the seesaw because the torque is going in the opposite direction.
And they cancel out.
Yeah, unless Jacob applies more torque, then there's actually a force in the clockwise direction as just happened.
Do not recreate this under any circumstances. Do not try this at home.
We are using our proper safety gear as we are performing these activities. Be safe in the lab, always. Safety is a priority.
Now we see that we have used proper safety equipment, i.e. Lizzie and I are both wearing helmets and Jacob is just supposed to be safe. Yay!
Yay!
Safety!
Hey, I like your shirt.
Hey, I like your shirt.
Wow, they see me rolling.
They hate 10.
Amazon was
Don't
supposed to ship
worry,
me
you're
a
rolling along right
Does
with
your
us.
physics
Okay,
hurt?
so Amazon was supposed to ship me my shirt. It's in the mail. It's on its way here. It'll be here tomorrow. I'm upset. Today is Tuesday. It'll be here Wednesday, May 25th.
Guys, remember, everything is physics. And sometimes that hurts.
That's
But
why
sometimes you just gotta get physical.
That's why you wear a helmet.
Yeah.
I
Put
took
that
mine
song
off.
in there. We spent an hour at Sonic
To get 6 corn dogs, we got 2.
It's National End of School Day at Sonic. We're doing 50-cent corn dogs.
Lizzy cam.
So it was supposed to be like $3 for 6 corn dogs, and we got 2, and we waited there for an hour. So we're a little upset.
This is Stacy.
That's my camera. Who gets the 2 corn dogs?
We're splitting it. We can all have half of one.
Half, okay.
Okay, Stacy, I don't know how to work this.
Mr. Few, have you ever wondered what torque is? We're gonna show you.
No, not Mr.
Jacob. Let me try another angle.
I can't remember the one thing that I need to remember torque is the topic.
That's better.
You guys having fun? This is what we learned in physics class.
It's violent.
Surfing USA.
Friction is opposing my movement as I go down the slide. Jacob has more friction than we do.
I am so full of static electricity right now. That's physics C.
Do a cute shot.
What if I like sit and then be like, thanks, Jacob.
This is the negative effects of torque.
We could do like one shot where like I'm.
Corn dogs.
We have to like tear it off. Yeah, like this. Okay, cheers to the physics project.
Cheers.
Cheers.
So worth it.
And that's a wrap.
That's a wrap.
Nah, don't even put music in that. Just record us singing it.
Physical.
And then put that.
Physical.